Hello friends and welcome to this tutorial on my YouTube channel. For my German followers, I'm sorry, this tutorial is English based. So what we're going to do is, hopefully you can follow along as well. But what we're going to do here is we are trying to solve a machine learning problem. Basically, we will use the Titanic data set from Kaggle. And what we want to do is we want to basically train an algorithm, in this case a decision tree algorithm, in order to make predictions whether a person would survive on the Titanic or not. Okay, and in this case, then I will probably use myself and put in some data, and we will see whether I'm surviving or not. All right, now let's get into this. The first thing I'm gonna do is I will import a few things. At first, I will import in this case I will import NumPy and pandas because these are the standard libraries, so I'll use them all the time. So I will import pandas as PD, and I will import NumPy just in case I will need it, NumPy as NP. And I will also import, of course, because I want to use the decision tree classifier. So in this case, I need to import it from the scikit-learn library. So I say from sklearn dot. In this case, you'll find it under tree. So sklearn.tree. I will import decision tree classifier. So decision tree classifier in this case. So decision tree classifier. And be aware of write it correctly, otherwise you'll get some problems afterwards. So decision tree classifier in this case. Okay. So I'll import my dependencies which I need, and the next thing will be that I will load my dataset. So in case you haven't seen it yet, I have an Excel file here. This is what it looks like. Okay. So this is what it looks like. We got a passenger ID, a survivor, passenger class, name, sex, age, whether the person has siblings or not, the ticket, the fare, the cabin, embark, and so on. But of course, there are a lot of data which we won't use because we do not need it. Because basically, for instance, the passenger ID or also the name of the passenger, has nothing to do with the prediction. So whether a person would survive on the Titanic or not, this is just noisy data which we do not need. So we will clean our data set before we make any predictions. So the next thing would be that I read it. So I could use pandas in this case. So I can say, in this case, my data set, for instance, just call it Titanic. Why not? Titanic. In this case is pd.read underscore CSV because it's a CSV file in this case. And then I would just paste the path. So I've copied that before, so I could simply paste that inside. So in this case, it's in my downloads folder. All right. So I have pasted that, and now we can print it just to take a look at what it looks like. So I can say simply type in Titanic, Titanic.head in this case, because I only want to see first two lines, and I could run this now. I could say simply run this in this case, run cell, in this case cells, run cells, take a look at what it looks like. And we'll see that's what it looks like currently. Okay, this is our data set. In this case, it's comma separated, but with pandas CSV file, of course, we get it in this nice data frame view. So we get the passenger ID, survive, passenger class, name, and so on. Exactly our data. So this works fine so far. So I simply insert a new line in. And by the way, you can see that I'm using Jupyter Notebook here. It's free, so you can download it. Okay, this is the first thing, and as I said, we need to clean up our data set before we can make any predictions, because currently there's, for instance, there's string data here, for instance, for the sex, whether it's male or female, and also there are a few columns which we do not need, so we will also get rid of those. And we can also see that there are NaNs, so missing data inside. This is also something we need to take care of. Okay. So the next thing would be that I'd say that we drop first a few basically columns which we do not need. So I can simply say Titanic dot drop in this case, and then I could specify which columns do I want to drop. In this case, I say labels equal to, and now because I want to drop several columns in this case, I will use a list. So I simply use list brackets and say, okay, I want to get rid of, for instance, in this case, okay, I want to get rid of the passenger ID, because this is something I do not need, and also the name. So I'll get rid of the name. So the name, and also get rid of the In this case, the ticket, for instance, because this is also something I do not need. So tickets, and I'll also get rid of cabin and embarked, because this is also something which I do not need here. Embarked. Okay, like this. And then also need to specify, of course, which kind of axis I want to drop it, because currently it's looking at the rows, but these are column names. So I specify axis equals 1. And I also need to use the in place parameter. So in place is equal to true, to really drop it from my data frame. Okay, this looks like that. And now if I print this again, run it, Titanic, and Nick cannot write that today, sorry. Titanic, okay, dot head, now I got it, dot head in this case, and we can run this, control enter, and you can see that my new data frame looks like that. So I dropped a few columns, especially string columns which I do not need. Okay, so this is it for that. And now insert a new line. And what will also, yeah, we could take a look at the data types, of course. So I could simply say, for instance, in this case, Titanic dot d types. Could look at it, could run this, and I can see that I got integers or floats, which is okay, because if I want to really train a machine learning algorithm, of course I need to have numerical data. So in this case, that works fine. But you can see that the sex, so whether the person is a male or female, this is still an object, and object in this case means it's a string. So this is something we need to take care of, and this is something we will do now. Okay. So the next thing would be that in this case I will use, you could do it with several different ways. For instance, you could use apply function, but in this case I will use the map function. So I'll make it well, easy for me. I simply use a dictionary. So I say convert numeric, for instance, is equal to, in this case I use a dictionary, as I said. So I say in this case, if it's a male, then use a 1, and if it's a female, then please convert this to 0. Okay, so like this. Okay, so I have set this, and the next thing is that I simply call my column. In this case I say Titanic dot what the column is sex, so Titanic dot sex is equal to, and now I say Titanic dot sex, call it, and I map it, so dot map in this case, and I will use my convert numeric. So convert numeric in this case, and this is it. Okay, so now if we run this again and for instance print it, so I could say Titanic dot head again, so I call it, and if I run this, press Control Enter, you can see that I converted my sex column, which was string, so male female, so I converted this to a numeric column, so with ones and zeros. And I could also, of course, see this. So if I call now, for instance, Titanic dot d types and run this, then you can see that now I've converted the sex into an integer, and this is fine because now I could use I could use my machine learning algorithm, in this case my decision tree, for that. Okay, do not need to run this twice. Okay, this is what we're doing here, and the next thing would be the missing data. So in this case, we have still missing data. We can't see it here, but if I, for instance, just check for it, I could say simply in this case Titanic dot isNull dot sum. So I simply call this function, and this should give me an error. Let's see, the object head sum is null. In this case, there, of course, I missed 2 parameters here. Sorry for that. So in this case, like this, and I run this, and I can see that in this case, this is my data, and I see that in my age column, this one here, that I have 177 missing data sets. So this just simply means that there is an NaN in this position. It's just not a number. It's just missing data. So basically, we do not know the age of these persons, and we need to deal with this as well, because we need a data set without missing values. So we need a complete data set. So what kind of options do we have? Well, basically we have 2 options. Either we just get rid of those parts of our data set, so we could get rid of those people where the age is missing, but this would also mean that we will lose a lot of data. So in this case, 177 persons, and well, How much is it? Well, if I call my shape, if I take a look at it, Titanic dot shape, this case, and I run this, then I can see I currently I got 891 people in my data set. So these are the rows, and the 7 are the columns. So in this case, those. So 1, 2, 3, 4, 5, 6, 7. And if I use, get rid of 177 persons, that's quite actually a lot of my data. So I could do something else in this case, and I want to do something else. I want to use, basically a fill method. So what I'm trying to do now is, instead of get rid of those people, I just use a kind of computer in this case, because I simply use the mean. So in this case, I just calculate the mean of my age column, and whenever data is missing, I simply put in the mean of the age of all the ages from the other persons. Okay, this is what I'm going to do. So okay, how do I do this? Well, simply spoken, I could simply use the fill na function. So I could say Titanic dot fill na. So fill not a number, so the missing values. In this case, I could specify it. I could say simply value in this case is equal to, now what kind of value I want to fill in. Well, in this case, Titanic dot a mean. So in this case, I will fill in the mean, and this is a great thing for pandas, because I could simply use really Titanic dot mean, and I do not need to specify the age column in this case specifically. So the data frame now will look through all the columns, and just simply, if there are NaNs, it will impute those NaNs, and simply use in this case, the mean of the column. But we've seen here that only in the age column there's data missing, so all the other columns won't be affected. Okay. All right. So okay, I run this, and you can see now if I scroll down, okay, I can see my whole data set. But in this case, it's imputed, and actually I have was no need, or was not necessary to print this. But if I simply get rid of this and say Titanic dot isNull, we could call this again. In this case, dot sum, and now, of course, if I use this mean function, of course, I need to use the in-place parameter again. So in place is equal to true. Otherwise, it won't affect my data frame later on if I use it again, and the missing values would be still there. So I run this, and now you can see that my age column, which before 177 values were missing, are now filled with the mean of the age column. So nothing is missing anymore. We get a complete data set. Okay, this is the third thing, which is important, of course. And now we could basically use a decision tree classifier, which we imported from scikit-learn. So we do not need to write it in this case. I could simply instantiate it. Now you can call it whatever you like. I call it tree because it's a decision tree, but again, use whatever name you like. And now I say decision tree classifier. So this is exactly the name for what we imported up here. This one from scikit-learn library. And I instantiate it with the 2 parentheses. And the next thing I'm gonna do is, basically I will train my tree. Okay, so I have to train my tree with the data which is inside. But before I can do this, of course, I need to do something else. Because so far we get a whole data set, that's true, but we got 2 things here. We got a survived column, which is basically what we want to predict, right? So this data set so far still needs to be split into basically our labels, what we want to predict, which is the survived column, and all the other inputs, which are the features, which we will use in order to predict the survived. Okay. So in this case, I get my column in here. So I have done some pre-processing steps, but before I could instantiate it here as well. But before I train it, of course, I need to split it. So in the survived as well as the other ones. So in this case, I'll simply say, survived. I could call it survived if I want to. Survived is equal to, and now I say reference to my data frame. In this case, a Titanic dot survived. Okay, I could call it this way. I could say Titanic, and I could use the dots, or I could also, of course, use brackets in here if I want this, and paste in the name, so survived. And if I print this now, simply just check it for a moment, survived. So print survived dot head. In this case, I print this survived dot head, and I run this, and I can see I get my survived column here. And this is just the index, okay? So zeros and ones, because ones means that the person survived, and zero means the person unfortunately died on the Titanic. Okay, so this is my survived column. And the other thing I need to do, of course, is I need to, well, drop the survived column from my data frame. So from this one, so I need to get rid of this, and I can do this the same way as I've done before. So I could simply say Titanic dot drop in this case. We've seen this up here, so we used it before here, and we specified the labels, the access, and the in place parameter. So we can do it the same way. So I can simply say dot drop in this case, and I say what do I want to drop? Well, I want to drop the survived column, so survived. I'll say access is equal to 1 and in place is equal to true. Okay, like this. And now I could call this, so Titanic dot head. Okay, and I can run this, and you can see that I dropped my survived column, but I saved it, of course, in the survived, because this is also what we need. We need the feature data set and basically the labels which we will check, and also of course we will use for training our classifier. So our decision tree, in this case our machine learning algorithm. Okay, so this is it for basically the preparation. And now what we can do, we could simply instantiate it. So far, I already instantiated here, so that's okay, but we can train it. Okay, you could say tree dot free, not free, tree dot train. In this case, dot fit, of course. Fitting just means training. Okay, dot fit. And in this case, I could simply put in my values, and I need my x values. My x values is simply my labels. So I could specify that. Could say x is equal to, and now I could. These are my features. I'm sorry. These are my features. This is simply basically my data set. So this data set, I want to use this data set in order to predict the 0 or 1. So it's a binary classification problem. I want to predict whether a person survived on the Titanic. So what I do is I fit my x values in here, and I use, in this case, Titanic, which is my data set. But I only use a part of this data set. So we have seen that this data set has 891 entries, so 891 person. But I will keep a small portion for my test later on. So I want to have a score. I want to basically at first train my algorithm, and then I want to test my algorithm whether it predicts or makes good predictions before I predict myself. Okay, so that's why we only use the columns until the 800. So I think it's, take a look. Yeah, 891 entries were in or are in our dataset. So I simply use the first 800 entries for training my classifier, so my machine learning algorithm, and the last 91 entries I will use those to test whether my classifier actually predicts or makes good predictions. Okay, so we'll use this, and I also, of course, then for the y value. So in this case, I say the y value is equal to survived in this case, so survived. So I'm referring to this one here, so it's the survived, so zeros and ones. And of course, these are also only the first 800. Okay, so these numbers need to match. Okay, so this is the second. Okay, so this is it for fitting the classifier. And the next thing, of course, would be basically to check whether our classifier makes good results. So in this case, I could simply say tree.score. So this would give me the accuracy in this case of the classifier. So basically, how often was he right in this case? So I simply could call a score method in here from scikit-learn. So I could say tree.score. And in this case, I'll simply use, again, x and y values in this case. So I could say x is equal to, and again, Titanic. But in this case, for the scoring, I will use, of course, my testing. So I simply use, in this case, from the 800 to the end. Okay. So in this case, I'll use the last 91, well, entries in my data set. And again, for the y, it's exactly the same. So I refer to survived in this case. And again, I will use the last 91 entries in order to, well, basically see the score in this case. G.score in this case. Okay, I could call this and I get a value. Let's see. Comma 91. Let me see. Oh, okay, run this. Okay, now you can see that in this case, I got an accuracy score of 81. This is not too good, of course, but this is just simply the process how it works so far. And there are a lot of things you can do to really improve this classification. But so far, in this case, the classifier was correct in predicting 81% of those 91 data sets in the testing data set. So whether those persons would survive on Titanic or not. And the last thing we're going to do here is simply make a prediction on our own. So in this case, I want to basically predict myself. So what I need for this is I need to have entries for myself for those feature values in here, okay? In order to get a prediction at the end, a 0 or 1, whether I'm surviving on the Titanic or not, or would have survived on the Titanic or not. And what I can do now is simply, well, come up with some data, of course, for myself. So I could say me is equal to, in this case, it's a NumPy array. So here I'm using NumPy, so I use np.array in this case. So I'm referring to an array, and now I need a data set, so one entry like this one here. So I need to, well, specify now my passenger class. I don't know. I'll just say I'm passenger class 1. Sounds good to me. The sex, okay, I'm a male. The age, in this case, I'm 28 years old. I have no siblings. Parch, 0. And fare, okay, how much did I pay to travel on the Titanic? I don't know. I can see here a 7. Okay, I did not pay too much. 7 in this case. Yeah, that's me. That is me. And now the last thing is I could predict using my trained classifier, my tree, which I trained here, which on the test, on the test data set, had a score at 81%. And so I could now predict for myself whether I would survive or not, with, let's say, around 81% accuracy. So how do I do this? Well, at first I need to reshape it, or myself, I need to reshape this array. So I simply say me is equal to me.reshape. And I reshape myself 1 minus 1, because it's in this case reshape it 1 minus 1 because I have several features in this case, so all those features, but it's only one entry, so I'm only predicting one person, myself, so that's why I'm reshaping it. This is something which is demanded by Scikit-learn. Okay, so I reshape myself, and the last thing basically is that I'm predicting myself. So I could say the prediction in this case, or I could simply call this actually tree.predict. And in this case, I want to predict myself. So in this case, I insert me. And then let's see. I run this. And I get an array of 0 in this case. And this just simply means that I would have died. So unlucky me in this case, I would not have survived on the Titanic. Because, again, this prediction should give us 2 options, 2 outcomes. So a 1 or a 0. In this case, I got a 0. So with 81% chance, I would have died on the Titanic. So lucky me that I did not travel on that ship. So this is it for basically this tutorial for using a decision tree. So basically creating a machine learning algorithm in NumPy and in Python in general. And yeah, thank you for watching. In case you want to see more, check out the link below the video. I'm referring to my Udemy courses. I have a lot of them. So if you are interested in those, check them out. So again, thank you for watching, and hopefully see you in the next video. Till then.